Hello everyone, welcome back to my channel. I'm Tepin and you're watching Tepin's Lab, and today we're going to learn how to do maximum parsimony using Paup 4. So, before starting, I would like to mention a few things. During our Paup analysis, we are going to do two types of analysis. The first one is heuristic search and the second one is bootstrap resampling. So, we're going to do two analysis. The first one is heuristic search, which will produce a tree with branch length but no node supports. Bootstrap resampling will produce a cladogram without any branch length but bootstrap support for the nodes. So we're going to use these two trees to generate the final tree that will be used in your paper or whatever you want to use it for. So let's get started with the first analysis. Okay, and also we're going to do both of these two analyses for partition and non-partition dataset. So first we'll begin with non-partition dataset, and this is the data that I have. Small data with 18 taxa, 18 sequences, and I've already aligned it using cluster and trimmed the ends, and this is the final alignment I have. And now, uh, before analyzing this uh, FASTA file, we have to convert it to Nexus file because Paup cannot recognize FASTA file. So to convert this, I've already converted this file here, you can see, but I will do it anyway. Once again, this is the messkit. You can open messkit and press Ctrl O and open ITST and OK, and then press enter. I mean save. Sorry, back, save, yes, then go to the end and select all these blank sequences. Don't know why messkit generate these blank sequences. Delete them. Going to matrix, delete selected character or text. Yes, you can see we have 699 characters. And Control plus S to save, or you can export it to Nexus file. The same thing. Close this one. And now open Paup. You can do the same thing here to open the file. You can see Control plus O. Just press Control plus O, and you can open the Nexus file. See all these things. We have 18 taxa and 699 characters, and skipping nodes is you don't have to worry about them. They are just mesquite blocks which was generated in the Nexus file. You can see here this all these things here are actually Nexus block. They are not going to affect anyway in our analysis, so we don't have to worry about that. And the analysis, and go to do the parsimonious analysis, you have to go to analysis and set parsimony setting. So usually you can keep this default because it is way better default. If you have to change anything, you can do that later. Okay, you can prevent it to collect branches if you like these things. You can choose to stop collapsing the branch also, but we are not going to do that. And go to H search, the first search that will produce a tree with branch length. And here we will set maximum tree to 5000. This is way more trees to save in case of my dataset, but this is the default values that most people use. But depending upon the size of your dataset, you have to understand how much trees should be saved. For example, if the dataset is very large, then you might have to save 10,000 or more, depending upon your dataset. And here you can just leave unchanged. Don't choose automatically increase by 100. For small dataset, that's okay, but for large dataset, it is going to take forever. And prompt for a new value, you don't have to, just don't choose this. If you choose this, you have to keep looking at the, you know, You can choose this at the beginning to see how much trees are saved in your analysis, but it won't matter. Just leave this one unchanged. And then starting tree, just leave them as they are. And here, addition sequence random, and we have 1000 replicate. And you can also choose random seed 1, 2, 3, 4, 5. And keep all these things default. TBR, they are best. And swap only best trees only. That's good. Then press OK. And the analysis is already done. So this is the heuristic search. You can see 8 search setting, we have already done it. And 270 parsimony informative characters. We have setting 5000 max tree will not increase, and you can see it is tried this much time of rearrangement, and only one tree was found best with 701 is the score. If you want to see the tree, you can show tree here and press show tree. You can see this is the tree. You can also change the outgroup 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 even before and or after analysis. That's not a problem here. You just have to copy the name. For example, I know I will set this as outgroup, copy, and then paste here, including the quotation. This as apostrophe. Outgroup has changed. You can see the tree again. This is the tree. Now you want to save this tree with the branch length, then you have to do little bit of typing. Save tree file, the name of your file. This is tree with mp branch length. Maximum parsimony with branch mp with branch length dot tree and branch length equal to yes. Press save and we have our branch length tree here. You can see this is the tree with branch length. But it will not have any support values. You can see no support values, no node support values, so you can just close it. And the next we are going to do bootstrapping, bootstrap resampling, put some support values at these nodes. So let's go to analysis and bootstrap jackknife, number of duplicate 1000, resample, random seed number 1 2 3 4 5, continue. And here we have to change few things. The stepwise addition, change this replication to 10, because if you choose 1000, then for this small data set it will not take very long time, but for data set with more than 50 taxa and more than 2000 characters, it will take very long time, like more than week or maybe months. So you can just keep this 10, or you can even keep up to 50. For small data set you can do it like up to 100. For large data set you can just keep it 10 or maybe 20. Let's just keep 30 for this analysis. Press OK. You can see even 30 is taking quite longer. If you keep this 1000, then it will take very long, even for large data sets. So it is produced tree, you can see here with node support values. All these node support values you can see. Now we want to save this tree. We have to save tree file mp bootstrap.tree. Here we have to do few other things like from to 1 to 1. This means from 1 to 1, the best trees that we are saving here from 1 to 1. And then we have save would be, that is save bootstrap node labels. Form, we need from, enter, or say save boot, not boot, save bootstrap parameter node levels as node levels. Then we have our mpph3. See, we have bootstrap values here. So you can see here there is no branch length. This is irrelevant to branch length, but we have node values here. This is the node values. You can see now we can use this one to put values in the other tree. You can see. So let me explain a little bit both these trees. So here we have Tropicoporus extensus lineatus and Tropicoporus extensus and lineatus. So this node is supported 99.8%. And we have Melioporus 100%, Flavelitus 51, and this node 100 and this node 100. Like this. This is how we are going to interpret. And you can use this tree in iTool and other website, or you can even save this as image and then edit that image and put these values in there. So that's how you produce a maximum parsimony tree with both branch length and bootstrap values. And also we are going to now check parameters. You can see tree scores, that is you can tree length, consistency index, retention index, and rescale and homoplasy index. You can go do this, press here, you can see this is here. Sum of maximum possible length and minimum possible length 556, and all this homoplasy index is very less, that's good. And this is how you do maximum parsimony analysis for non-partition dataset. So in the next video I'm going to explain how to do maximum parsimony for partition dataset. So thanks for watching.